Hello and welcome back. So far we have understood how to build linear regression model, multiple linear regression model, polynomial regression model, and we have known how to select the best model using resampling techniques. Now let us try to understand how exactly the thetas are being found when you actually train a linear regression model. So this is called a solver. Right? There are two solvers for linear regression model. One is normal equation, second is gradient descent. The algorithm we used is from scikit-learn and the algorithm name is linear regression. The algorithm is based out on normal equation. So let us try to understand how normal equation works because it has got some limitations and advantages. Based on the algorithms or the solver's limitations and advantages, we need to choose the algorithm. Okay. So we have so far seen how to choose an algorithm by looking at the residuals versus fitted graph by understanding the pattern, and then by doing model selection approaches. The other parameter to choose a algorithm is how the algorithm works or the solver works. Based on the limitations and the strength, we need to actually choose the algorithm. So we need to understand the solver behind the linear regression algorithm. To understand, we need to understand some little bit of matrix, the linear algebraic concepts. Let us try to understand those linear algebraic concepts first, and then we'll understand the normal equation. So diagonal matrix, right? When there are all the off diagonal values are 0, we call that as diagonal matrix. You see this? Right? Diagonal values are non-zero and non-diagonal values are zeros. The same, the D2 also the same thing. All the diagonal values are non-zero and off diagonal values are 0. So this is called as diagonal matrix. The identity matrix is a special case of diagonal matrix where you will have all ones in the diagonal. The beauty of identity matrix is when you multiply any matrix with I, or I multiplies any matrix, you will get the matrix A. A into I is equal to I into A is equal to A. This is like 1 in your numbers. When you multiply any number with 1, you will get the same number. Right? That is identity matrix and diagonal matrix. And let us understand what is inverse and singular matrix and what are the problems involved in calculating inverse for a singular matrix. So to calculate inverse of a square matrix, we can use this formula 1 by AD minus BC D minus B minus CA. If the matrix is A, B, C, D, this is the formula to calculate the inverse of a matrix. Here the AD minus BC is called as the determinant of the matrix. So let us try to take a simple example and calculate the inverse 8351 and calculate A inverse 1 by AD minus BC. What is A here? 8, B is 3, C is 5 and D is 1. AD minus BC, and then D is 1 minus B minus C A, and this is like 8 minus 15 is minus 7. So when you divide, this becomes minus 1 by 7, this becomes 3 by 7, this becomes plus 5 by 7, and this becomes minus 8 by 7. This is calculating inverse. A singular matrix is a matrix where determinant is 0. If you look at this matrix 5, 5, 3, 3, if you try to calculate AD minus BC, AD is 15, BC is 15. It's equal to 0. When you try to calculate inverse, it gives you divide by 0. Right? Here it gets 0. Divide by 0 is undefined. So you cannot calculate inverse for a singular matrix. Especially, if you look at this matrix, right? These two vectors, right? The first vector and second vector are dependent vectors. Okay? So, this concept, singular matrix concept is useful because in normal equation, the equation generates singular matrix in some cases. Let us try to see them in the normal equation. Another linear algebraic concept you need to understand is symmetric matrix. Symmetric matrix means the upper triangular values and the lower triangular values are same. If you see 1, 1, 3, 3, 6, 6, this is a triangle, right? This is another triangle. The upper triangular and lower triangular values are same, or if you fold it, you will get the the values are same. If you fold on the diagonal, right? 3, 3, 6, 6, 1, 1. right? It become, that's called as symmetric matrix. Now the example for a symmetric matrix is heat map. The correlation matrix is a symmetric matrix. If you see experience and experience the relation, experience and salary here, again salary and experience, right? This value and this value are same, this value and this value are same, this value and this value. So upper triangular values and the lower triangular values are same. Okay, that's an example of symmetric matrix. So these are the concepts you need to understand before we jump in and understand the normal equation solver. Thank you.